So for today, we started off with a precalc review question, and I gave them this triangle that was sides 7, 8, and 9. I said, find angle C, the one between the 7 and the 8. So on purpose, we named that angle, the one we care about, C, because then we use the law of cosines. So then we stick in all the numbers, or A and B, and the only thing we don't know is that angle, big C. So then we get it down to this. And at the end, you're going to do inverse cosine to get that answer, and you will have a calculator. So you will have to actually do this and get the answer. And there's going to be a few people that get it wrong, not because they don't know what they're doing, but because they don't check something on the calculator. Everybody take a second and hit mode and see if you are in degree mode. Because if you're in radian mode, that would have just burned you right there. Totally changes the answer. Completely changes the answer. Okay, so be in degree mode to get your answer. And then you're going to do inverse cosine. There's no reason to reduce that now. You can just write 32 over 112. Your calculator can handle it just as well. And did you get 73 point, I'm going to round here, 73.4 degrees. Raise your hand if you got that. Okay, cool. All right. Any questions about that one? That was using law of cosines. All right, if this had been a right triangle, do you get it been super way easier? Let me just show you. Here's a right triangle. That's a 3, 4, 5 classic right triangle. What if I asked you for this angle? Well, then right away, I personally like sine, but you could use tangent. You could use cosine, but let's say I'd say sine of that angle is 3 over 5. Then couldn't I just do inverse sine? Boom, done? Yes, I could. Or what if I said tangent of that angle is 3 over 4? And then couldn't I just do inverse tangent on both sides? Yep, boom, done. It'd be the same answer. Okay. So that's so much faster. Why? Because it's a right triangle, and they're nice. All right. So, in your packet, in your travels through your packet, does anybody run into one that they did, looked at the key, and were like, oh my gosh, I still don't understand that? If so, I'd be willing to take a question. I'll do a lot more questions tomorrow, but today we got to save time for that top 20. You don't have any suggestions? I'm totally cool with picking some myself. Yes?
I haven't gotten a packet.
Oh, then you may want to come up here and grab it. Anybody else need a copy of the pack? Do you need me to bring it to you, or is it a question?
No, it's a question.
Okay, question.
So, I was just like confused on
Problem number?
problem 25.
Number 25. Would you please read me problem number 25?
What was it? 8 different
Sure, it's extensive. Tell me what part you want help with, because I got to tell everybody at home who doesn't have the packet in front of them, what problem are we talking about?
The first one was inverse cosine of 2 squared over 2.
Of 2 square roots of 2? Is it like that?
No, square root 2 over 2.
Oh, root 2 over 2. Okay. You want me to do that one?
Yeah.
Okay. So a reminder of how these work. First of all, it's inverse trig. Right away, I gave you something that I would memorize, and we're not going to give you, which is that little chart that says where inverse cosine can even live. Do you remember that it only is allowed up in here? So then these are immediately out. If it's an inverse cosine question, you got to have that memorized. The range of inverse cosine is from there to there, which is 0 to pi. And now I'm going to rewrite it a different way. Cosine of the angle equals root 2 over 2. I like this for 2 reasons. One, this should make you see it as a circle trig question where you're going to draw a triangle and stuff. And number 2, it makes it clear what you're trying to find. Theta is the angle. That's what you don't know on an inverse trig question, and you're finding the angle. So when we're done, the answer to this is an angle. All right, so now I'm gonna try to figure out, should I put it in quadrant 1 or 2? What do you say, Vivian? Quadrant 1 or 2? Yeah, because why?
Because that's like those are all of them are positive.
Yep. And cosine isn't positive here. Cosine would be negative there. So I'm crossing that one out. If I put ASTC, it may make it more clear. Only sine is positive there. All right, so then this is the cosine shaping up to be root 2, 2. And then if you haven't memorized this one yet, you guys have this one memorized? 1 root 2 is the same exact thing as root 2, 2. Did you know that? All right, so that would help. So that tells me it's a 45-degree angle. But really what I want to know is, what is that angle? What I would have done if I were you is I would have figured out this third side, and when it came out to root 2, are you with me? When it came out to root 2, then I would have known, oh, if these two are the same, it's got to be the 45, 45, 90 triangle. And then it's 45. Why can't I say 45? Because the answers have to be in radians. So what's the final answer? 5/4. There you go. That's an example of an inverse trig question. So,
on that same problem,
Yep.
what would be like cosecant, inverse cosecant of 2?
okay, we'll just do a different one here. Inverse cosecant of 2.
Square root 3 over 3.
Wait.
Sorry.
You just changed it on me. Do you want
I wanna do this.
do you want inverse cosecant?
Inverse cosecant
Okay.
of
Inverse cosecant.
negative 2 square root 3
Negative 2 square root 3
over 3.
over 3. All right, so right away I go, okay, I'm going to flip this thing because I don't like cosecant. I don't want to deal with cosecant. So I'm going to switch it to the sister function sine of some angle, but then I got to flip this. So then it's 3 over 2 root 3. And I hope you understand that negative could be on the middle, the top, the bottom. It does not matter. But I know from circle trig that the negative is never on the hypotenuse. You know what I mean? So then I may as well put it here. But it could have been in front. It doesn't matter. All right. So now there's a big but on this. But this was inverse trig. So that means since I changed this to a sine question, it's only allowed from here to here. So these two are out. And since it's negative, it can't be here. And now I got my triangle. And now I got my sides. Sine is opposite and hypotenuse. And I can't see it yet, but I think I know this is the 30, 60, 90. So what would I do? I'd figure out the third side. Always figure out the third side. Okay? And I think it's the 30, 60, 90 because I think what's happening is they multiplied everything by 2. But I could be wrong. So, in the end, they want the angle for this one. Did you make this one up in your head, or did you pull it from the
It's on the sheet.
from the sheet? Okay, all right, just check. Because if you make it up in your head, you can end up with angles that are weird because the numbers aren't like logical. But all right, so I'm going to figure out this third side. So to do that, my that's not famous. My fast way to do this is square root of, and then I can square the other two. So negative 3 squared is 9. And, oh wait, the other one's bigger though, so I'm going to put it first. This one, when I square both parts of it, 2 squared is 4, root 3 squared is root 3 times root 3, which is like root 9, which is 3, and then the 2 squared was 4, that makes it 12. And am I on the longest side? If so, I would add them. And I'm not, so I'm going to subtract them. All right, so then this is the square root of 3. This side here is the square root of 3. You get how I did that?
Then what's the angle?
Okay, so now I got to figure out what the angle is. Is this 30, 60, 90? Or, well, first of all, let's rule out something. Would you agree it is not a 45, 45, 90? So then it's probably the 30, 60, 90. Now, if you want to know for sure, though, my advice has been to draw another 30, 60, 90. And which of these is the smallest side? Can you tell me which is smaller, root 3 or negative 3? Which one's smaller? Yep. So then when I draw my triangle, I'm going to make it a triangle that's a 30, 60, 90 and see if it kind of matches up. So this one is got the smallest side here, 1, 2, square root of 3. Is this just some mutant version of that?
Yeah.
Yep, it is. And here's how I can tell for sure. Let's do that proportion thing. Root 3 is to what? 1. Like, pick another one, I don't care. Negative 3 is to square root 3.
Negative square.
You're right. Yep, because we're going down, so technically we should make that negative. All right, so then if I multiply this across, do cross multiplication, do they come out equal? Yep, it is just a mutant version, and here's another way to say it. I could have just multiplied everything by the root 3. Process that for a second. Do you get it was really just a disguised 30, 60, 90 triangle? That was a tough one, no doubt about it. But hey, you're an honors pre-calc, so we're supposed to give you the tough ones.
So then it's negative pi over 3.
Since it was an inverse trig question, you got it right, it's negative. You know, remember we started with an inverse trig, so then this is the negative zone. So you caught that, that's awesome. Negative, and then am I across from the smallest side? No, that would be the 30 would be over here. And then I'm across from the bigger side, so this must be the 60.
So it's
Negative pi over 3. Make sense? All right. You picked one of the toughest ones, so that was smart to ask about it. All right. So we're going to have a lot more chance to ask questions. Keep fighting through the packet, but don't do it all. Seriously, you want to leave yourself some. Because if you stop right now, like because you finished the packet, you have a week. I have nothing else to give you. Okay? So just keep getting a few done each night. What you don't want to do is curse yourself with 5 pages of the packet to do the night before the final. Okay? So just keep working through it slowly. We'll do a bunch more practice tomorrow in class. And today, the rest of the hour, I'm just going to give you the top 20, and then when you finish that, you can work on the packet some more. All right? That's all I got for you for the video for today.